So you should turn those in today, but if you don't get them in until tomorrow, that's okay, because I haven't even put our last set of homework. No, maybe I'm thinking math 8. But this is quarter 2 now, right? So like, I don't want to confuse anyone with discovery days. I wait to post those grades. I have them in my book, right? Like old school teachers where you didn't have the internet. I have a grade book. I've got all your grades there. So even if I gave you the papers back yet and they're not in math, they're gonna go in math. So if you have a check minus or something, please take care of those. See you at some point today or tomorrow. Turn in 225226. We're gonna check 231 next week since I'm not collecting it because we wanna do more practice of that stuff together. So guys, look, same with 232. Yeah, it's not gonna be due till next week. We'll check it next week if we even have time because remember like mastery days and Outsiders Day and everything. So check out your graph that we had from Andre's Juice Shop, and now check out his graph. Right, I wanted to leave this up here so people could kind of see that. So take a moment to talk with your team. Does Andre's graph look like your graph? What happened, and is his graph good? Like, is it a good graph, or do we need to help him out? Talk with your team for a minute. Yeah, absolutely. This is not the right class. So Eli, and actually you may have been my last card yesterday, so I should probably shuffle. Eli, what'd your group say? Do you like this graph? Is it a good graph? Why not really? Whoa, John. Eli's talking. Oh, the scaling over here is all messed up. Is his x-axis good? Goes up by 3, then up by 1, then up by 2, then up by 3. What? This is all sorts of messed up. What did Andre do? He made it look pretty bad. See what I did? So he made it look good, but the numbers are all messed up. This doesn't actually graph what we're supposed to be graphing. So if we go back to Andre's data, in case anybody missed it from yesterday, these were our days in smoothies, right? And we said, okay, we have approximately 40. We're going to split it among 10 boxes, and I'm going to give 4 to each box, right? We said, sorry, I'm trying to get my dot camera back out. So our graph looked like, wait. Maybe. So we had these 3 points. And then I asked you guys to make a couple more. Day 0, they would have probably sold 0 smoothies because day 1 would have been the first day selling. So my 3 points, or I got a few points I still need to graph. I guess only 3. 9, 20. So if you were still working on this, let's finish this together. So 9 all the way up to 20. 10, 28. Ooh, good climb there. And then 12, 38. Does our graph go in a straight line? So our graph should look approximately like this. Yeah, guys, it doesn't go in a straight line, which is a good thing for their business because check it. If we stayed on the straight line of the first couple days that they sold these smoothies, our sales wouldn't be that good. So what they're doing is they're overperforming. They're getting better, right? Sales are going up. So we could also say if we try to draw this as our line, which you don't have to draw a line on your graph. I'm just doing this so we can talk about it. if we drew this as a line, we could say, well, the first few days we didn't do very well, and then we started to perform how we really want to. But guys, like, we can't just put the points in a nice straight line, because then it actually doesn't show us what we want to see. The fact that this is going up is a really good thing, because they're making more money. Does that make sense? Any questions on our smoothie graph? All right, now, especially for my artists in the room, I want to fight with you. And what I mean is I want to argue that art and math go right together. Because a lot of times, my art people are like, absolutely not. So maybe we don't need to fight. Maybe this is a good thing. I want to convince you that what we're doing, and guys, just take a minute. I'm actually debating. I shouldn't say that out loud. So I want to convince you that what we're doing is not just for graphing. It's really just for anyone that wants to like bullet journal or make things look nice or like ever wants to like make a spreadsheet or anything. So you'll see this is my advisory group, right? This is my like graph paper notebook that I really like because it doesn't have holes over here, so I get a nice clean look. So I decided I wanted to make a paper for my advisor where I could just like make little notes because we're heading into the first Discovery Day, and I like to keep track of what Discovery Days people do. So like kind of through the year, I can see like Discovery Day 1, Discovery Day 2, Discovery Day 3, and then at the end of the year, it's really fun to talk about like what you learned through those Discovery Days. So what I did was I counted up my entire page, right, all the boxes down the side, like my y-axis essentially, and that was 53 boxes. Then I said, well, I have 13 advisory students, but I also want to put a header at the top of the page. So that'll be one more space. So I really have 14 sections that I want to create. So the math, like 14 like lines, 14 sections. So I said, I want these all equally spaced out to look nice. So I did 53 boxes of the entire paper, divided by 14 sections. And this is what I was trying to explain yesterday that I don't think we had enough time for. My label comes from the math we did. So division always actually kind of makes the word per. So if anytime you talk about prices or things like that, and the word per is involved, means somebody did a division somewhere. So I get 3.78. I don't want partial boxes. So should I round up or round down when I only have 53 boxes on my paper? Round down. I can't round up because then I won't fit on the paper. So I went ahead and said, all right, 3, and my label is boxes per section. So I'm going to give 3 boxes per section that I create. And I'll have some extra paper left over because I rounded down, but it ends up looking really nice and fitting everything I want on the same paper. So what I'm really trying to like help us know how to do is like make really nice looking notebooks or bullet journal or to-do lists or things like this. And yeah, there's math involved and we're going to graph some numbers and stuff. Because like, I don't actually think that you're going to be out in your real life and go like, oh, I should make an XY axis and graph this information. I don't actually think that, right? I'm not crazy. But I do think you're going to do things in your life that you need to know how to do division and split things up nicely and make stuff look good. And that's why I think we should all learn math. So we're going to practice again with some numbers, but I'm going to slowly try to convince you that we're not just doing math, right? I'm helping you know how to do art and all sorts of things. So do me a favor and let's copy this table down really fast just so it's easier for you to look at. So somewhere on your graph paper, and if yesterday you used the top of your graph paper, I should put this middle of the screen. If yesterday you used the top of your graph paper, you still have a bottom half open. And this is 122, but it's actually B. We're going to do B first because it talks about Columbus. So I'm going to, over here on like the far right side of my paper, I'm going to copy that table. So you can just call it visits, and then we could just do a $sign. So this is the Columbus Rec Center, which actually their prices have probably gone up. Columbus is pretty well known, like in the U.S., because when you think of Ohio, everyone kind of thinks of Columbus. Like if you've read Ready Player One, it's set in Columbus, Ohio. Hey, but if we want to make our life easier, sorry, nobody caught me on that one. Let's go in order. So let's change the order of the data they gave us. And if you already started, it's fine. You can do whatever you want. But I'm going to go low to high. I'm going to go 18. But then my next number, okay, 29 does still work as my next number. But then, guys, the jump to 100, I don't really like that. I'm going to write down the 62 next. And the cost that goes with the 62 is $97. The next number up would be 84. And what goes with the 84 is 119. Next biggest number is now my 100. 135. And 114. And 149. And then if you want to make it look a little nicer, put some lines across here to keep things all separated. We're going to call the visits our X value and the cost our Y value. So over here, we can go ahead and draw some axes. I can extend this axis if I need to, but I can only go so far because then I'm going to run into my data table. So we could go ahead and label visits, but leave space for some numbers, right? I'm leaving space for numbers once I decide my scale. And then over here, works nice as a label, dollars, I can keep this written vertically. So what we need to do now, just like what we did yesterday, is scale our axes by doing our distance divided by the amount of boxes we're going to use, which might be different on your paper than my paper. That's why I'm not going to do it up here for you. I'm going to walk around and help people if you need. Take the total distance we need to go. So what's our biggest X value? 114. That's our distance. But we could round it to 115 or 120. Right? We can go past that. Make it a nicer number if you want to. I think 120 is a pretty nice number. What's a nicer number than 149? 150. So if your axis goes to 150, that's good. You'll be able to graph all your points. Chat with your teammates. If you're using the same graph paper, your graphs could be identical, but you and your teammate might have different graphs. Would you like a ruler?
I don't know where mine is. Mine's like
well, there's a broken one here that'll do everything we need it to do. But guys, also a reminder, there's a box of rulers up here. I'm just trying to keep some things sort of spread out. So we've got rulers back there, but now we're out. We've got rulers right here too. Oh, and I'm missing a calculator. If you have a calculator, mind, please bring it back. They should live in this room. Anyone else need a ruler? Just makes life so much easier. Oh, you got one.
So how many do you have across?
Who needs help? I am happy to come help you. Actually, that was a really good idea, because now your graph can just go here. Man, I was silly. If you put your table on the left side of your paper, then your graph can just go on the right side of your paper. Maybe we should start to do that. Jesus put his graph over on the left side, or like his table, and then he's got all the space on the right for his graph. Need some help? We're going to count how many boxes. And we're going to take the distance we're going divided by how many boxes. Or guys, guys, you can like use. John, you owe me a ruler. You had it for 30 seconds. Have your group see me after class. Quit testing how far plastic bends. You'll break it and you'll owe me a ruler. 1, 2, 3, 4, 5. So guys, give me your attention real quick because I will give you a hint if you're struggling. My Y value, that is the biggest, is 149. We said we're going to round that to 150 just because it's a nicer number. 150 nicely divides by what? 10, or not as nice by 12. What about 15? What if I did 150 divided by 15? That'd be nice too. So if you go all the way up to 15 boxes, that'll be a nice number to divide by. Or we could stop, because I think a lot of us probably did this, 14, 13, 12, 11. If you go to 10 boxes and make that your 150, guys, what is our quantity of 150 divided by 10 boxes? Each box will get 15. So if you use 10 boxes, I'm going to scribble this out because I'm only going to use 10 boxes here. We would scale it 15. And then I'm going to act like I never extended this axis, right? Because I don't really need it. Guys, here's a trick. Give me your attention if you would like another trick. I could use just 10 boxes down here, but 120, so I'm going to act like this is 120. 120 divided by 10, I'd have to count by 12s, and that's kind of annoying. So if instead I use my approximately 120, and how many boxes would make this nicer? 120 can divide by what number really nice? Yeah, but 6 isn't very big. Yeah, I just said 10 makes me count by 12s. What if we strategically use... You with me, Katie? What if we strategically use 12 boxes? What's 120 divided by 12? 10. So that'll let me count by 10s if I use 12 boxes. So you can use whatever you want, but sorry, now I'm trying to talk and write at the same time. I'm just trying to make your life easier. So if you can get a way to make your division equal 10, then you can count by 10s. Needs to go out to 120 because, well, needs to go out to 114, but 114 isn't as nice of a number, so go past it, right? Go to a number bigger than the max that we're trying to get to. Because 0, 0 is always what's over here, and you only need to go up to the max number that we need to use way past the max number that we need. I would honestly probably grab a scrap and graph paper and put it over there. So give me a second, I'll get you one. you have this data written down, right? You should have this table on your paper. If you're done with the axes, plot these points. If you're done with the axes, plot the points. So once we have our axes drawn, we're going to try to make our life easier by saying if I use 12 boxes, and if I say this is 120, right, we'll round up to get past it, 120 divided by 12 is 10. So then every box is worth 10. Does that make a little sense? If I count 10, 20, 30, 40 out to 120, I'll fit. If I do count by fives, I won't fit on the paper. That makes sense? You have to choose a number big enough. So we always want to round above. You're right. You're right. It would round to 110, but we always want to go up in graphing so that we can graph past, like so that all of our points fit on the graph. Does that make sense? That's why we're going to call this 150. So what I did up there is I used 10 boxes vertically, and 150 divided by 10 got 15. So each of these boxes is worth 15 each. Does that make sense? So go ahead and label that first one 15, and then you can go ahead and do the rest of the labels, like counting by that much. Okay. I have those right now. You can do it right now if you want. He like spill a soda on it or something? Yeah, it is kind of weird that things are sticky. Maybe like rained in his car. I don't know, but then it gets humid and things get sticky. I don't know. Anybody else need help with their axes? We're not chopping wood, but we're playing with axes. That joke will land with approximately nobody. You had more? Can I steal this for a second? Because it's good. I want to share that it's different than mine. Alright, so Kylie, look up here real quick. I want to show you that mine is not the only option, right? Kylie's using a whole piece of graph paper. Awesome. And for her x-axis, which we said needs to go up to 120, she had a lot more boxes to work with. So, do you remember how many boxes you had to work with? I think it looks like it was probably like 38. So when we do that number of boxes, or sorry, the distance that we need to go divided by the number of boxes, we get approximately 3, a little over 3. Sorry, I know you can't really see that probably. But so then we use less than that number. So it's showing 3.15. There we go. So Kylie used 3 boxes for every chunk of her scaling and got out to 120. I love it. Love, love, love it. And then her graph is going to be bigger and kind of easier to work with. You could have chosen a bigger scale here. I know you kind of copied me. Yeah, you could have gone by 10. So yeah, it gets easier the more we do it. How we doing over here? Good? Let's go ahead and plot the points if we're ready to. Yo. Yo. Yo, yo. A lot up and down here. That's a lot of pens. Did you need something or are you just saying my name? I don't know. I haven't grabbed my points yet. Compare with each other. I don't know. Guys, the further we get into the school year, the more I'm going to act like I don't know what I'm doing and we have to do this together. 1853. So I'm a little under 20. Got to go up to 53. So guys, notice. Hey, hold up. If you're still working, that's great, but I'd like to talk for just a second. Notice that like it's a little hard to figure out where 53 is because I jumped from 45 to 60. So the more we graph, we might start to realize like if I make a bigger graph, it's kind of easier because I can find my numbers more easily. So like sometimes keeping my graph small makes things harder. So like sometimes we use an entire sheet of graph paper. Like you'll do that in science some this year, I'm sure. We use the whole piece of graph paper for one graph. 2965. 6297. If you have not put your points on, please try to do that. 84, 119. What do you mean? Whoa! We are a safe space here. That does not feel very safe to say something like that. It's kind of rude. And, Deekshita, my points are looking pretty nice.
Yeah, yours look exactly like what I did.
That's why we got to be careful throwing shade. Might come back at us. Guys, this tells us something. If your points are in the right spots, they should actually line up. Guys, give me your eyes for a second. What this actually tells us, look at my screen. There is a fee to join the club, right? The Columbus Recreation Center. There's a fee because zero visits still cost money. Whose parents have a membership to a gym and don't go as much as they should or say they, yeah, me. But, well, before the pandemic, right? Before the pandemic, like, I worked at a gym, hardly ever went, like, on top of this job, right? I rock climb. We haven't really probably covered that yet. There's a fee even if you don't go. That's how gyms make their money. But then when you go, certain places like the rec center charge you every time you go, especially if you want to do things like go swimming. Sometimes that's an extra fee, right? So this is how many times they've gone and how much it costs them. And it goes up nice because it costs the same thing every time they go. There was an initial fee just so they could like be members, and then every time they go, it's the same. If your dots aren't in a straight line, that's totally fine. The reason for that is it's hard to find our exact numbers, right? It's hard to find those exact numbers. Any questions on this problem? We're going to try to do another one, but slightly faster. Not like, we're not in a race. There's no reason to be in a race. Here's our new table. So this table is from, I think, from Cleveland. No, it's not specific. So the table at the right shows the time it took 5 different students to get to the mall and how far they traveled to get there. You'll see we got much smaller numbers this time. Give me a second. I'm going to blow this up, make it bigger. Go ahead and copy this table down. But if I was you, I'd put it in order from low to high. Like the left is almost always going to be our x-axis, and the right is almost always going to be our y. Guys, I don't know about you, but I need a clean sheet of graph paper. Yeah, I don't like using the back of graph paper. If you do, that's fine. Yeah, you use pencil, not pen. You got me there. Lucas boldly uses pen. So guys, a lot of times we're gonna like not use the whole piece of graph paper. So I would advise like fold your paper hamburger style, make your life easier, but that's up to you. I'm gonna take the advice of Jesus and I'm gonna put my table on the left side of my paper. So let's label this. What number is it? This is 122. We're still 122, but we're on A now. So
Wait, is it 2-122?
yeah, you don't really need the 2. Distance and time. Guys, I would put this table on the left side of your paper. I'm going to start with the smallest number in the left column, which is 0.5. The next one is 1.7. Yeah, 2.2 would be next. My hand just hurts. My wrist hurts. I'm trying to hold paper down. Thank you for your encouragement. All right, so our X, what's our maximum X? 4.1. Let's call it 5. Right, let's just call this 5. And then instead of, whoa, wait a minute. Our maximum Y is not with our maximum X. Well, that's interesting. But still, this is our maximum Y, right? It's our biggest amount of time that we have here. So when we make our axes, and guys, I'm going to start to be strategic because I'm not working in pencil, and I really probably should be. Get bigger. There we go. I'm going to just put my origin. Go ahead and do this with me real quick. And start my axes. But I'm not going to go very far at first. My Y wants to get to 20. If I have 20 boxes, I can just count by ones. Right? Like for every box. So you could count and see, do we have 20 boxes available? Ooh, it's going to be close. I don't think I do. I don't. So if I don't have 20 boxes available, guys, what I'm thinking in my head is I want to divide the distance of 20 by something. By a number of boxes. Yeah, I have 18 boxes here. That's not nice math. 20 divided by 10, I heard somebody say could work. Ooh, that's going to be real. Like, if I only use 5 boxes, my graph's going to be really small. 20 divided by 10 would work, but, hey, I want your attention still. I would actually like you to do this with me like this. If I, instead of using 10 boxes, use 15, remember that's a distance of 20 over 15 boxes, we can reduce that to 4 over 3. Guys, I'm trying to help you practice these funky, like 20 divided by 10 would have been too easy. I want to help you with a more difficult one. This tells you do a distance of 4 every 3 boxes. Sorry, I keep forgetting my S on there. So what we do is count 3 boxes, mark it as 4. So 1, 2, 3, this is going to be our 4. Another 1, 2, 3, this is going to be 8. Another 1, 2, 3. I need to move my other stuff out of the way so you can see how this is like nicely using up most of my space. Right, here's the space I had to work with. I used up almost all of it. We want to spread out as much as possible. So Dikshita gave the suggestion of just use 5 boxes, which we could, but then my graph would be really tiny and hard to work with. So for my x's, even though I only need to go to 4.1, do we just want to use 4 boxes? No, that'd be silly. So, let's see how many boxes we have. Go ahead and count it up. Ooh, I got 20. I got 22, but 20 is a nicer number. So your graph paper might be different than mine, but walk through this with me one more time. So hey, put your pencil down for a second, because I just want you watching and making sure this makes sense, because we only got 5 minutes left. If I want to use 20 boxes, it doesn't actually matter what I put on top and what I put on bottom. So I'm going to show you this flipped over to show you that it's okay if you set it up differently. If I want to use 20 boxes and split them among a distance of, well, I need to go past 4.1, so what should I go to that'll work nice with 20? 5, and that's my distance, right? This reduces, I can divide them both by 5 to 4 over 1, and that tells me my 4 distance only uses, now I'm messing up my labels. 4 boxes is 1 distance. So like yesterday, scooch this up a little bit. Every 4 boxes is 1 distance. It doesn't matter which 22 card pickup. It doesn't matter which way you set up that fraction, that ratio, because it's just telling us what to give to what. Doesn't matter if boxes is over distance or distance is over boxes. We just then use that to tell us what to do. And see how we nicely use up our space? Yeah. You can label other things if you want to. So you could label like every half if you felt like it. It might help us if we come over here and split these up and say, okay, 6 is right there. Okay, 10 is right there. Now, this graph is going to be different than the last one. And I want to encourage you to raise your hand once you figure out what I mean by that. I can't not. Y'all get a piece of candy because you're just flipping awesome. You're just like killing it. Everyone's just working really hard. And it's just like, I just can't. Everyone I talk to is like, you teach middle school? Oh my gosh, how do you do that? I'm like, it's easy. They're awesome. When you blow me away, you just.
You just said it.
But I wasn't talking about math. You guys chose. So we got decimals. We had to space things out a bunch more.
But say you're going the very first one, 9 as the y. There's only 3 between the 8 and the 12. So it's not like each one is 1. So you have to find like exactly where.
Yeah, we made some funky scalings. Also, does this graph go on a nice line?
No.
Yeah, what, like, we go up and then down and then way up and then down and then up again. Guys, you don't like, we don't have to connect these, but if we did, it would look like this. Guys, this is how frustrating it is to take public transportation in a city that doesn't do it well. What this graph is showing us, if we label our axes, is how far somebody was going, right? So the literal distance